Hi there, this is Imaneo. Welcome to my channel. So in this series, as you might know, we are going to implement a game using Flutter and Flappy game engine, and it is called Flappy Dash. So the point is that we are using the same mechanic that we have in the FlappyBird, but we only replace the bird with the dash that we have here. And this is the 6th episode. If you haven't watched the previous episodes, I highly suggest you to watch them and then watch this video because it's a series and you need to watch all the videos from the first video. And yeah, so in this video, we are going to take a look at the collision detection topic. So it's a method that helps you to detect when two objects intersect or they collide with each other. And for example, here we have a player that we want to realize when the player hits the pipe or collides with the pipes. So this way we can implement the game over logic. Or suppose that we have a coin in between of the pipes. So this way the player can collect the coins and then we can increase the score. So this is the collision detection. We need to realize when two objects are collided each other, and this way you can implement your own logic. And to do that, Flame has some options for that. So you just need to add this mixin into your game. So it says has collision detection. So this way Flame knows that, okay, there are some collidable objects in the game and it's gonna take care of the collisions. So then you have a callback to listen the collisions. And yeah, so with this mixin, you tell the Flame knows about the collision detection that you have. And there is another concept called ShapeHitbox. So ShapeHitbox is the area that you want to implement the collision. So it doesn't necessarily match with the UI that you have. For example, you have a body or you have a character in your game and you want to implement a logic, and when the bullet hits the head, you want to implement the headshot animation. Or if the bullet hits the body, you want to implement another kind of animation. So this way you can define different hitboxes, different shapes hitboxes for the character, and then you can implement different kind of logic. So it doesn't necessarily match with the UI or with the character that you have. So Shape Hitbox has some implementations. For example, one of them is rectangle hitbox. So it just has the width and height and also the X and Y. So it's just a regular rectangle that we have. And also, yeah, for example, here we have polygon hitbox. So it is something that you have different points that creates a polygon. For example, you have a more complicated shape or object. So for that you can use polygon hitbox. Or here we have circle hitbox. For example, for our player that is here, we can use a circle hitbox because it's a circular object. And for the pipes, we can use rectangle object. And yeah, so this is the concept of the hitbox, shape hitbox. And the other thing that I want to talk about is the collision type. Yeah, so this is something that you define when you define your shape. And we have three kind of collision types. It is active, passive, and inactive. So active is a type that collides with all of the hitboxes that you have. For example, in our game, we can set the player as an active collision type. And the passive type collides with only the active type of the hitboxes. So suppose that in our game, we set the pipes as a passive collision type. So this way they don't collide with each other. So there's no callback, and that's fine because in our game we are not gonna implement a logic for when two pipes collide each other. So it's better to define the collidable objects as passive. So this way you have better performance in the game. And yeah, so the other type is inactive, that will not collide with any other type of hitboxes. So it is totally inactive. It is for when that you don't want to listen anymore for a hitbox or shape hitbox to fire a callback or collide with the word. So yeah, it is for when that, for example, a character dies, or maybe when you collect a coin and you can make it inactive to prevent a duplicate callback. And yeah, so for our game, we are gonna use active for the player, which is going to actively listen for the collisions. and we are gonna use passive for the pipes, that it doesn't matter if they collide with each other. We don't want to listen to that callback. So that's why we use passive for the pipes. And also we will use passive for the coins. So suppose that we have some coins in between of the pipes and we don't want to coins collide each other. So that's why we can define them passive, and because the player is active, the player can collide with the coins, also with the pipes or any other type of component that we have in the game. Yeah, so I think this information is enough for the implementation of the game, but you can read the documentation. We have some other concepts. For example, there are something called broad phase for the performance optimization, and also we have ray casting and ray tracing. So it is for when you want to fire a line to see if it collides with something in the world. And yeah, but this is not something for our to take a look at the moment, but I will put a link into the description so you can take a look by it yourself. Okay, now let's find our game. It is here, and we want to, let's remove this import. And let's add the mixin. What was that? Has collision detection. So this is the callback that we need to implement. Now the game detects the collisions in the game. So yeah, this is the mixin that we need to add. Yeah, by the way, let's change the branch to part 6. As you know, in each episode we have a branch, so you can check the source code, you can compare it, and so on and so forth. So let's check out to part 6. Yeah, this is the only file that we changed right now. Okay, now we need to define the shape hitbox for the player or for the dash that we have here. So here I'm gonna call add circle hitbox. Yeah. So as you remember, circle hitbox is one of the types that shape hitbox has. So if you take a look, it has 3 different of shapes: rectangle, polygon, and circle. And also you can customize your own shape. And also there is a concept here. It is called composite hitbox. So using this class, you can create a complicated shape of hitboxes. For example, you can combine 2 rectangles to create a hammer, a shape of hammer in your game. And yeah, so this is for when you want to combine some collision shapes to make something that is more complex or complicated. And for the dash, we just added the circle hitbox. And the point is that if you turn on the debug mode, you can check the shape that you have. So this way we can make sure that it is working correctly. And for now, I just disable the movement. So let's run it again. Okay, so as you see, we have a circle here that is drawn by a yellow color. And so let me remove the background to make it more visible. I'm gonna comment this code, and if I hot reload, yes, now you can see that we have the yellow circle here. And yeah, you know, in real games, we make the collision shape a bit smaller than the actual UI or the character that you have. So this way it feels more precise. So it feels more precise, and also it feels more easy to play. So we don't want to detect the collision when the pipe hits here because it is not part of the UI, you know. And to do that, let me open the dash here. And here we have something called radius. So let's say that it is size.x divided by 2 to see what is going on. Yeah, so this is the default radius that we have. So let me call it radius, and we are gonna multiply it by 0.98, for example, to see how does it look like. Yeah, and the point is that we need to make it center. Let's see what we have here. We can say position is size divided by 2, and anchor is anchor.0.center, sorry. And if you run again, yeah, so now we have the collision shape in the center of the player, and it is 80% of the full size. So it is not a full circle, it is 80%. And maybe we can move it a little bit down to make it more precise on the player. So we can change the position. So let's say that this is the center, and we can multiply it by 1.1, which it moves 10% on bottom and 10% on the right to see how does it look like. Yeah, it feels better. And yeah, so let's keep this one. Maybe we can try 70% to see how does it look like. No, it doesn't feel good. 75%. Yeah, I think it is better, you know. We can check it in the game. Maybe we need to change the numbers later. Yeah, so now we can create some coins in between of the pipes. So it is hidden, I know. Later we are gonna remove them. I mean, remove the visual part, but for now let's define them with a visual component or visual shape. So here we are gonna create a new component called hidden coin dot, and it's hidden coin extends position component. And in the constructor we want to have the position, and for the size we are gonna say it is a vector2 of 22 on 22 or 24 on 24. And what's the problem here? Yeah, so let's do like this. Size is gonna be a vector2 of 24 on 24. And yeah, so in the render callback we are gonna just draw a circle, and the radius is size.x divided by 2. Paint is gonna be basic palette dot yellow dot paint, and center is gonna be size divided by 2. And we need to have offset here, and the size is a vector2. So now we need to use 2 offset. And yeah, so I think we are done with the render part. We are gonna call the super.render to make sure that everything is fine. And now we need to add this component somewhere. So we need to add them in between of the pipes that we have. So as you remember, we have a pipe pair component. So it is the combination of 2 pairs that we have. Yeah, here we are adding the bottom pipe, and this is the top pipe. And in between we are gonna add a hidden coin. So let's import it, and the position should be 0 and 0. Yeah, so the position is relative, and it is relative to the pipes that we have, and 0 and 0 means here. As you remember, we are changing the y point of the position of the pipe. So the bottom pipe has gap divided by 2 on the bottom, and the top pipe has gap divided by 2, but it is negative, so it goes up. And in between we have a space that is our gap. And now we are just adding the hidden coin in between of them. So let's run the game to see how does it look like. Yeah, so as you see, we have a coin here, but the point is that it is not fully centered. So let's turn on the debug mode and run it again. Yeah. Oh, so the point is that you see it is rendered in the square, so it is fine. But the point is that Flame is grabbing it from the top left. So as you remember, we have a concept called anchor, and it is top left by default. So we are gonna change the anchor to anchor.center. So this way the flame engine grabs the component from the center point. And oh, it is the center of point of the pipe pair. Sorry, let's use it in the hidden coin. Yeah. Okay, so now it looks good. And also we need to add a hitbox for the coin. So we are gonna use onload method, and it's gonna be a void. And here, yeah, and here we are gonna add a circle hitbox again, and this one is gonna be a passive. So let's say that collision type, yeah, as you see the default parameter is active, so you can define it as an inactive type because they are not colliding with each other. So this increases the performance. So try to define as much as inactive collision shapes that you can in the game. And if we run the game, you see that, yeah, there should be a yellow circle around that, but as the color is 0, we cannot see that. So let's change it to maybe dark gray. And yeah, but let's stop the pipes. So here we have the movement, and yeah, so as you see there's a yellow area here, and it's the collision shape that we have. And yeah, so it is working well. And now we need to listen to the collision that happens when player hits the hidden coins. To do that, we can implement the collision callbacks. So yeah, this is a sample code. For example, when it collides with the rectangle, it detects and it changes the rectangle color. And yeah, so you can add this mixing into the component that you have. For example, it is our dash, and let's add it here, has collision callbacks. And then you can implement the on collision. So you have on collision and on collision end. So for this case, we just need to implement the on collision because it doesn't matter when it ends the collision. We just need to realize when the collision happens. And here we can just add this callback, and yeah, it needs to call the super method. Yeah. So as you see here, we have some points that is the interaction points that we have when two objects are colliding each other. And also we have other, which is a position component. So this way we can check if the other object that we are colliding is a coin or is a pipe. So here we are gonna check if other is coin or hidden coin. Print, let's increase the coin. So we can just take a look at the logs here, and if we run the game, so we need to enable the movement for the character and also movement for the pipes. And if we run it again, yeah, it doesn't work. Let's debug it. Okay, so let's see, what do we have here? Here we have the circle hitbox that is active by default, and here we have the hidden coin. Oh, it's the mistake that I made. So we need to use passive instead of inactive. So we need to have passive for the components that they are not colliding with each other, but we want to make it able to exist in the world, and the active character can collide with this one. But if it is inactive, it doesn't work at all. So let's run it again. Yeah, so you see that we have something in the log, so it seems it is working well. And to make sure that it is working well, let's add a line here to say other.remove from parent. So this way we are just removing the hidden coin that we just collided with it. So this way we only print this one time or once per coin that we collect. So let's run it again. Okay, so you see that we are collecting the coins, and it is just printing the statement once. And yeah, so this way we can implement the scoring system. And also let's implement the collision for the pipes. So this way we can have the game over logic. And yeah, here we have the pipe, and we can say add rectangle hitbox. Let's run it to see how does it look like. It seems working well. So there are two rectangles on top of each other, and we are gonna just print the if statement here. We can say if other is pipe, print game over. Okay, so let's run it again. Yes, so you see that the game over is printing, and when we collect the coin, it just works well. And now let's remove the debug mode here, so we don't need it anymore. And we have debug mode in somewhere else. Yeah, it is in the pipe pair. So now we don't have any debug mode, but yeah, so let's remove the visual part of the coin, because we are not going to have this in the game. We just want to increase the score when the player passes the pipes. So this way it feels like that when you pass the pipe, the score increases. So we don't have any real coin here. And to do that, we just need to remove the render part. Yes, as you see here, we don't see anything, but you see that we print something here in the console, so it increases the coin. And if you enable the debug mode, you see that we have the yellow circles here that determines the shape that we have for the hitboxes and for the hidden coins. And now let's move them a bit further to make it feels like that when you pass a pipe, the score is gonna be increased. So at the moment it is like the starting point of the pipes. So to do that, I'm gonna find the hidden coin. Yeah, it's here. And for the position, yeah, we are gonna add it here. For the X, I'm gonna add maybe 10 to see how does it look like. Yeah, it seems better, but let's try 20, 30. Yeah, I think it is better. So this way you pass a pipe and then the score is increased. And yeah, so let's remove the debug mode. It was in the coin. And yeah, so now we have the scoring system. I mean, we just detect a callback when the player collects a coin. Now we can just add a number here. So we are gonna define a variable in the Flappy Dash game. So let's define it as a score, which is 0 by default. And now let's add it to the game. So we can use game.camera.viewfinder.add. So viewfinder is something that you can add your component on, and it doesn't exist in the world. It is just on the camera. So it's like a camera lens, and you can just add your components there. And here we are gonna add a text component. So we have a text component that just renders a text in the screen, and the text is gonna be a score.toString. And if we run the game, yes, you see that the score is in the center and the position is 0 and 0, I believe. And so let's check it. Yeah, so because this is the 0 and 0 point in the game, so let's move it in the Y position by game.size.y, which is the height of the screen, divided by 2. And now we need to make it negative to move it upward. And yeah, so now the score is on the top. And now we can have a reference of the text component. It's gonna be text component score text. It's gonna be a late variable, and we are gonna initialize it here. And yeah, so in the update method, we are gonna change the text to score.toString. And this way it is going to update the score every time that it renders the components. And we can have a function, for example, increase score. And here we just increase the score by 1, and it's gonna be rendered in the next frame. And in the dash component, we are gonna add it here. So when we collect a coin, we are gonna get the game. So we need to add has game ref, and it is a Flappy Dash game. So now we have access to the game, which is the Flappy Dash game. And here we can say increase, what is this? It is a Flappy Dash game. And oh, by the way, we are implementing it in the word, I think. Yeah, okay, we can get the word and increase the score. Yeah, that's fine for now, because in the next episode we are going to implement state management using block library, and it is just a temporary code. And so let's remove this print statement. Yes, so as you see, the number is increasing, the score is increasing when we pass the pipes, and when you collide with a pipe, the game over is printed here. And yeah, so I think it is enough for this video. And so as a recap, we just got familiar with the collision shapes. So we have circle shape, we have rectangle, we have polygon, and it is how the collision detection works in the Flame engine. You need to define the shapes, and then we have collision types that are active, passive, and inactive. So in our game, the player is active, and the pipes and the hidden coins are passive. So they don't need to collide with each other. That's why we set them passive. And the player is active, and the player can collide with all the collision shapes that we have in the game. And inactive is for when you don't want to do anything with the collision. So it is totally inactive. So it seems like that it doesn't exist. And yeah, so after that we just showed the number on top of the screen. And one important point is that when the collision happened, when you collect the coin, we just remove the coin from the word or from the system to prevent it from calling the callbacks again, callbacks that are related for the collision. And yeah, so in the next episode, we are going to implement the game over logic, implement the page that shows the game over. We are gonna implement the state management that holds the state of the game, for example, when it is in paused or playing or game over, and also the number of score that you have. And we are gonna use block library for that. And yeah, so that's it. Stay tuned for the next video. Don't forget to hit the like and subscribe button, and share it with your friends, so this way I get motivated to work more and publish more videos. And see you in the next video. Bye.